So the first step then is just to create a new file here. It's going to be standard Objective-C class, and it's going to be Lua Engine subclass of NS object. Create that inside of our main project. And let's just put those guys up the top there so we can access them. Now inside of our Lua engine, what we're going to want to do is have a Singleton Access method that's just going to allow us to get hold of this Lua engine from anywhere inside of our program. So we'll use this standard sort of idiom that we always find for those kinds of accessors. And the second thing we're going to want to do is actually run our engine. This is where I talked about the runtime. So we'll call that run Lua. And let's go ahead and implement those two functions. And this will be our Singleton Accessor. It's going to have a local static that's going to actually refer to the instance, which is going to be one of these. So we'll use our template from the Grand Central Dispatch that just gives us a nice singleton. And inside of here, the engine is equal to Lua engine, allocate and initialize. And then finally we'll return that instance. Here in our initializations, we want to have our state of our Lua engine stored for us. So obviously we're going to need to access our Lua implementation. So the way I'm going to suggest to do that is actually to import the Lua HPP. Now that is the C++ style header file. And if we just go and have a look at what is contained in there, it's just going to give us a nice extern C. Got an error, and here it is. It's telling us that I don't understand how to compile this. I'm looking for a parenthesis at this point in the compilation. And the reason for that, why that is that this file that we're including it from is actually going to be compiled as an Objective-C file. So what we need to do is tell our Xcode compiler that we're going to compile this using C++. And in Xcode that's very simple. We're just going to add the .mm extension, so when Xcode passes it to CLang, CLang will say, hey, this is one of these C++ / Objective-C, so I'm going to need to run this through something that understands C++. So now that we understand C++, let's just go ahead and actually add in a place to put our state. So that is going to be inside of a private API. To the rest of our Objective-C, as long as I keep this interface here nice and clean for Objective-C, so I have Objective-C only classes further down in my project that are going to include this file. So I do not want to have anything that is C++ polluting this namespace. So I want to centralize all of my C++ code into this .mm file. So I can't stress that enough. If you get some kind of wacky compile errors, it's going to be because you've allowed symbols to creep out into the rest of your code. So in order to prevent that from happening, what I'm actually going to do here is create a private interface using the class extension functionality of Objective-C and the nice Xcode template to give me that. So it's going to be a class extension of our Lua engine, and inside of here I'm just going to add in the Lua state pointer, which is going to be our Lua state, and that's going to basically hide that away privately so that we can be fairly sure that people aren't tempted from other parts of the project to access that. So here in the initializer, we're going to set that Lua state up, and it's going to be equal to Lua new state. Now let's just have a quick look at this function. Any function that starts off with just Lua by itself, those 3 letters, that's going to be one of the more lower level raw Lua functions. Something called Lua L is actually going to be defined inside of one of Lua's auxiliary libraries. So here in this case it's the auxiliary library that's just going to give us a nice little convenience function based on our additional checking that's done over on top of our raw function here, which is at the base library level. So that's the pattern that you'll find as you use Lua. Access these library functions to get nice higher level abstractions on top of the raw functionality. So as I mentioned, by default Lua is nice and small, and part of the reason for that is that by default it only includes the interpreter. If you're really worried about security and you're sure that you're not going to need any of the Lua system access stuff, like accessing your environment or doing printfs out to the command line, well then what you can do actually here is avoid even having to open any libraries at all. So what we're going to want to do is do a Lua library call again, and in this case we're going to use the library call that just nice and conveniently opens the standard Lua libraries like maths and Lua environment and process and so on. And this is the standard pattern that you always get when you're accessing Lua functionality is you make a Lua call and then you pass in the Lua state. As somebody pointed out when I was giving my presentation yesterday, you can think of this as being the VM, the virtual machine of Lua, and because it's nicely snapshotted away here into this state variable, you can pass this around inside your thread and you can have some fairly good guarantees that you're not going to have issues with concurrent access. Now, of course, concurrent access is always a bugbear when you're doing threaded programming. It makes it entirely re-entrant because you know that all of your state is wrapped up in that variable. Now we should probably just do a little bit of error checking here because at this point it's the first time we're accessing the Lua state, and it could possibly be null if we've run into some memory problems. So let's just add in a little bit of error checking here, and we'll do nslog and just say, okay, could not initialize Lua